Finite differences and interpolation. Today we will see the examples based on the Gauss forward and backward interpolation formula. First of all, we'll see the Gauss forward interpolation formula and then we'll solve the examples based on that. So the Gauss forward interpolation formula is y is equal to, or we can say y of x is equal to y naught plus r into delta y naught plus r into r minus 1 upon 2 factorial into delta square y minus 1 plus r plus 1 into r minus 1 upon 3 factorial into delta cube y minus 1. Now how to take all these terms like delta square y minus 1, delta cube y minus 1, that will be clear to you while we'll solve the examples. The next term will be plus r plus 1 into r minus 1 into r minus 2 divided by 4 factorial into delta raised to 4 y minus 2 and so on. Let's see how the arrow pattern is formed while solving the examples using the Gauss forward interpolation formula. So this type of arrow pattern will be formed like y naught, then down arrow, then delta y naught, then up arrow, then it will be delta square y minus 1, down arrow, delta cube y minus 1, up arrow, delta raised to 4 y minus 2, down arrow, and so on. One thing you need to remember that this formula can be used to evaluate the values of y for r between 0 and 1. Now let's see this with the help of an example. Find y of 3.3 using the Gauss forward interpolation formula. The table is like this. X values are from 1 to 5. Y values are 15.3, 15.1, 15, 14.5 and 14. Now here our x value is 3.3. As our x value lies between 3 and 4, so our x naught value will be equal to 3. Now h, which is the difference between the x values, so the difference over here is equal to 1. And r is equal to x minus x naught divided by h, which will be 3.3 minus 3 divided by 1. That is, it will be equal to 0.3. Now we'll create our table. This table is known as the central difference table. As we are having 5 values of x and y, so we'll go till delta raised to 4 y. Now here there is a difference in the table like we used to create a table in which there was x and y in the first and the second column when we were solving the questions of the Newton's forward and backward interpolation formula. But here, while you are solving the questions using Gauss forward and backward interpolation formula, we'll have one more column which is r. Now here, as it is necessary that we can evaluate between 0 and 1, so wherever your range is in which you are evaluating, there you will write 0 and 1. So here we are evaluating between 3 and 4. So there we'll write 0 and 1. Above those values will be -1, -2, and then below it will be increasing by 1. Above 0 it is decreasing by 1, and below 0 it is increasing by 1. Then the y values are same, which is given in the question. This will be delta y, then delta square y, delta cube y, and delta raised to 4y. Now again the difference taking is same, that is 15.1 minus 15.3, which will be minus 0.2, then 15 minus 15.1, which is minus 0.1, then 14.5 minus 15 minus 0.5, 14 minus 14.5 minus 0.5. Now for delta square y it will be minus 0.1 minus minus 0.2, that is minus 0.1 plus 0.2, which will be equal to 0.1. Then minus 0.5 minus minus 0.1, that is it will be equal to minus 0.4, and minus 0.5 minus minus 0.5, which will be equal to 0. Then minus 0.4 minus 0.1, which is equal to minus 0.5, and 0 minus minus 0.4, which is 0.4, and 0.4 minus minus 0.5, which is equal to 0.9. Now previously we saw the arrow pattern. We'll create arrow pattern like this. Start from 15. Why we are starting from 15? Because our x0 is 3, and the value that we have to find, that lies between 3 and 4. So one down arrow, then up arrow, again down arrow, and then up arrow. So your 15 will be your y0, delta y0 will be minus 0.5, then delta square y minus 1 will be minus 0.4, delta cube y minus 1 will be 0.4, and delta raised to 4 y minus 2 will be 0.9. So this is how we show the arrows while solving the question using the Gauss forward interpolation formula. You just need to remember that you have to take the values between 0 and 1. That is, r should be between 0 and 1. There only you will start your first arrow. So here, as we started it between 3 and 4, corresponding to 0, the value of y is 15. That's why we started showing our arrow from 15. Now we just need to input these values in our equation. Y of x is equal to y0 plus r into delta y0 plus r into r minus 1 upon 2 factorial into delta square y minus 1 plus r into r plus 1 into r minus 1 upon 3 factorial into delta cube y minus 1 plus r plus 1 into r minus 1 into r minus 2 upon 4 factorial into delta raised to 4 y minus 2. Now we just need to input all of these values. If you have shown the arrows correctly, then definitely you will get correct answer while you use the Gauss forward interpolation formula, because everything just depends on these arrows. Now our y0 is 15, delta y is minus 0.5, r we have found, which is 0.3. So just place these values. Our delta square y, that is delta square y minus 1, is minus 0.4 plus 0.3 into 0.3 plus 1 into 0.3 minus 1 upon 3 factorial into delta cube y minus 1 is 0.4 plus 0.3 plus 1 into 0.3 into 0.3 minus 1 into 0.3 minus 2 upon 4 factorial into our delta raised to 4 y minus 2 is 0.9. So whole thing multiplied by 0.9. So it will be equal to 15 plus minus 0.15 plus 0.042 plus minus 0.0182 plus 0.0174. Again, I'll just repeat that wherever you have your value that you need to find, like here our value was between 3 and 4, so there you will write r equal to 0 and r equal to 1. That is, near 3 it will be r equal to 0, near 4 it will be r equal to 1. Above 0 the values will decrease by 1 and below 0 the values will increase by 1. Now we'll see the example based on the Gauss backward interpolation formula. First of all, let's just see the formula. Y of x is equal to y naught plus r into delta y minus 1 plus r plus 1 into r upon 2 factorial into delta square y minus 1 plus r plus 1 into r minus 1 upon 3 factorial into delta cube y minus 2 plus r plus 2 into r plus 1 into r minus 1 upon 4 factorial into delta raised to 4 y minus 2. And so on. So this is the Gauss backward interpolation formula. Here the most important thing that you need to remember is that we use this formula to evaluate the values of y for r between minus 1 and 0. Before we saw in the Gauss forward interpolation formula that we can use it to evaluate the values of y for the value of r between 0 and 1. And here it is necessary to remember that we can only use this formula to evaluate the values of y for r between minus 1 and 0. This will be clear to you while we will solve the example. The question is, x and y values are given to us, and using Gauss backward interpolation formula we have to find the value of y when x is equal to 38. So here 38 will lie between 35 and 40. Our x value will be equal to 38 and our x naught will be equal to 40. Why 40? Because it's Gauss backward interpolation formula. So for Gauss forward interpolation formula, you will see the value to the left of the value that you need to find, And for Gauss backward interpolation formula, you will see the value to the right of the value that you need to find. Then our h will be the difference, which is 5, and r is equal to x minus x naught upon h, which is 38 minus 40 divided by 5. So it will be equal to minus 0.4. Again, we'll have to create the central difference table. Here also the second column will be for r. Then third column y, fourth column delta y, fifth column delta square y, then it will be delta cube y and delta raised to 4y. Because we are having 5 values of x and y, we'll go till delta raised to 4y. Just write the x values. And now, as our value that we need to find, which is 38, lies between 35 and 40. So what we'll do here, where you see this 35 value, there you will write the r value as minus 1. The y values will be same as given in the table. Corresponding to 35, write the r value as minus 1. Corresponding to 40, write the r value as 0. Above minus 1, decrease the value by 1, and below 0, increase the values by 1. So it will be minus 2, minus 1, 0, 1, 2. Now for delta y, again the same thing, that is we just need to take the difference of the values of y. So it will be 14.9 minus 15.9, which is minus 1. Then 14.1 minus 14.9, which is minus 0.8. 13.3 minus 14.1, which is minus 0.8. 12.5 minus 13.3 is minus 0.8. Now minus 0.8 minus minus 1, which will be 0.2. Minus 0.8 minus minus 0.8, which is 0. And minus 0.8 minus minus 0.8 is 0. Then 0 minus 0.2 will be minus 0.2, and 0 minus 0 will be 0. And lastly, it will be 0 minus minus 0.2, that is equal to 0.2. Now we'll just input all of these in our formula. But before that, we'll start creating our arrow pattern. So as we are using the Gauss backward interpolation formula, we'll have to start from the value which is corresponding to 40. So start showing arrows like this. From 14.1 go up, then minus 0.8 go down, again go up, and then down. So this is how you'll create the arrow pattern while solving the examples based on the Gauss backward interpolation formula. Now all we need to do is just to input all of these values in the formula. So y of x will be equal to, our y naught is 14.1, then r is minus 0.4. What is delta y minus 1? It is minus 0.8. Then delta square y is 0. Delta cube y is minus 0.2. And delta raised to 4y is 0.2. Here in delta y, I have encircled the wrong value. It will be minus 0.8 only, but it will be the value which is near the arrow. So this will be multiplied by 0.2. Now on solving this, we get 14.1 plus 0.32 plus 0 minus 0.0112 plus 0.0045, which is equal to 14.4133. So this is how you can solve the examples based on the Gauss forward and backward interpolation formula. You'll find my notes on my website. The link to it is in the description. Thank you.